we still need what to subtract fractions? What did we have to find yesterday all day long for addition? Yeah, we still need a common denominator. So we need the denominators to be the same. All right, so I'm going to look at my first example. Again, do you see so much more simple than yesterday because it's only one thing? Okay. So I'm going to take a little quick survey and see what I see in my denominator. Do you see how I see an x and I see a 7? Okay, so my common denominator is going to have to include a 7 and an x. That's my only choice. So I like to write myself a note so I remember, okay, this is what my common denominator was in case I forget. Let's look at our first fraction. If I want this to have a denominator of 7x, what does it need in the bottom? 7. A 7, right? So if I multiply it to the bottom, what was our rule about that?
You gotta multiply it
to the top too. Okay, so do you see how I achieved my common denominator of 7x now?
Yes.
Okay, so then what does this one need to be twins with this one? An x. And if I multiply it to the bottom, I have to multiply it to the top. Okay, so let's have our denominator be 7x because, well, that's what it is, right? Let's multiply. What do we know 5 times 7 is, or what does our calculator tell us it is? 35. Again, wherever you're at this morning, we will meet you there. Calculator, brain power, we're good with you there. And 3 times x is just what? 3x. And do I have any like terms that I can add or subtract up top?
No.
No. So this problem is done. It's almost like we can breathe easier after yesterday. So the addition were a little bit harder, and then I forgot that I had really taken it down a notch with the subtraction. And like I said, my notes did not match this. So I'm glad I peeked at that quiz this morning. Okay, let's look at the next one. We need a common denominator again. What would be a good common denominator if I have a 2 and a 4? 4. Because I can't really backtrack that into a 2, right? Like that would be hard. So can I turn this into a 4?
Yes.
Yes. So let's make our common denominator be 4. So backtracking isn't really a thing. It's kind of moving forward and making it bigger is our thing. Okay. So do you see how this one already has the common denominator? That one's good to go, yeah? Does this one already have the common denominator?
Nope.
What does it need?
It needs a 4.
It needs a 4. How can we make it 4?
It needs another 2.
Yeah, it needs basically another 2. So I'm going to multiply by 2, and again, if I do it to the bottom, I have to do it also to the top. All right. So my denominator is 4. So that's going to carry through. In the top, when I multiply right here, 2 times x is 2x. And then I have my minus 5. And that just stays. Is there anything I can add or subtract in the top that are like terms? No. So this will be my final answer. Good? Easier than yesterday?
Yeah.
Much, right? Okay. Let's come down to number 3. Again, the first thing I think about is what would be a good common denominator, and I like to kind of make myself a note. So what would be a good common denominator for 3? 2, and also what do I need though? X. Because I can't somehow magically like do a magic spell and make that x disappear, but I can give this one an x so it matches. Agree? So we're always making things bigger. We can never backtrack and make things smaller or disappear, but we can make things bigger. Okay, so I'm going to give this one an x. If I give the denominator an x, what else do I have to do? Yeah. Yeah, they both have to get an x. All right, so now my common denominator is 2x. Anything happening with the 7?
No.
Not so much. So there's my 7. There's my minus. What do I get when I do x times x? X squared. Can I combine 7 and x squared? Are they like terms?
No.
No. So this would be my final answer. Good? Yeah. So these are kind of one step. Now, granted, we have to do a little bit to get to that one step, but one step. All right, let's think common denominator again. What would be a good common denominator for number 4? 9, yeah, because we can't backtrack the 9 to a 3, but how can we make this 3 also a 9?
Times it by 3.
Times it by 3. And if you multiply it to the bottom, you have to
Do it to the top.
do it to the top as well. Okay, so my denominator is now 9. 3 times x,
3x.
and then I have my minus, and then I have my 5. Any like terms that I can combine?
No.
No. So I'm ready to box it in and call it a day. All right, can we try some more?